Today, on how it's made. Sulkies, putting the cart before the horse. Bagpipes, we overcome our kilt complex. Yule logs, no trees died to make 'em. And fishing lures, the real story. In the sport of harness racing, the horse, known as a standard bred, pulls its driver in a sulky. A sulky is a cart on two wheels that attaches to each side of the horse's harness. It has to be sturdy enough to withstand the rough ride, but it also has to be lightweight so that it won't slow the horse down. Step 1 in sulky production is to cut an aluminum tube 4 centimeters in diameter for the frame. Most of the parts are aluminum because it's a lightweight metal. Using a manually operated tube bender, workers shape the angles of the sulky shaft, the piece that attaches to the harness. Now they weld together the 8 aluminum parts that make up the sulky's frame. All this welding takes approximately 2.5 hours. Once that's done, they insert the shaft into the bridge on which the driver sits, making sure they align with each other. Next come the clamps, 7.5 centimeter long steel pieces with a hole on each end. They fasten certain non-welded parts of the sulky together. Each clamp starts off straight. A worker mounts it on the machine called the bender, then pulls a lever almost 360 degrees to curve it. Next, a tool called a multi-press drill fashions the aluminum flange, the part of the wheel hub to which the spokes attach. The multi-press has 6 bits. It rotates 3 times to drill a total of 18 holes. The flange has another 9 holes to remove weight, and 6 smaller holes to which a plastic wheel protector will later attach. Now they position the flange on the aluminum hub and hammer it on snugly. They do this using a tool called a punch to avoid leaving impact marks. Next, a sleeve goes inside the hub and a bearing goes in between the two. Again, with the help of a punch, they knock on the bearing snugly. Finally, they install a cap to prevent dust from getting in and causing damage. The hub is now complete, and it took only about 5 minutes to assemble. Now they attach aluminum spokes, 18 of them, on each side of the wheel. Every spoke attaches to the flange on one end and to an aluminum rim on the other. Workers hand tighten the nipple on the rim end of each spoke. The nipples are made of brass because it resists rust quite well. It's essential to tighten all the nipples equally to ensure the wheel will be properly aligned. After tightening them further with a screwdriver, on goes some rim tape, then the tube and tire. They pump up the tube with up to 35.5 kilograms of air. Then they install a plastic protector disc. This prevents competing horses from putting their hooves through the spokes. Meanwhile, the sulky has been sandblasted, painted, and decorated. Now it's time to put stirrups on the shafts. These aluminum and stainless steel fittings on the end of the shafts are what attach the sulky to the horse's harness. Should the harness break, a backup safety strap on each shaft keeps the sulky attached to the horse. Now they fasten a padded leather seat to an aluminum plate mounted on the bridge. On each side, they attach the wheel to the bridge with a simple axle. Even though these look like bicycle wheels, they're stronger and far more durable. Next, they assemble what's called the tree, the rigid stainless steel structure that goes on the horse's back. The outer part is made of plastic. They stitch Velcro to the underside. To that, they attach a nylon-covered foam padding that protects the horse's back from irritation. The finished harness with all its hooks and turrets weighs 4.5 kilograms. It's taken 20 hours to make. This is what's called a quick hitch fitting. It hooks onto the fitting on the end of each shaft, tying the sulky to the horse's harness. A sulky takes 40 hours to assemble. It weighs between just 23 and 28 kilograms. Harness racing is one of the few sports where being a lightweight is key to a good track record. The bagpipe is one of the oldest instruments. To play it, you blow into a pipe attached to a leather or synthetic bag, then press on the bag to force the air out through other pipes to create sound. You transform this sound into a melody using finger holes on a reeded pipe called a chanter. They start by carving a 20-centimeter long block of wood, rounding it to a diameter of 4.5 centimeters. It's part of a drone, one of 3 on the bagpipe, that create bass and tenor harmonies. They drill a hole that will later become an air channel. Using a lathe and a plastic template as a guide, a craftsman spins the wood to carve it, a process called turning. The lathe has a stationary carbide-tipped cutter, strong and precise enough to cut this hard African blackwood. It's a very heavy and dry wood, perfect for turning. For more intricate decorative cuts, he uses a handheld device called a combing tool. Next, he uses what's called a parting-off tool to make additional decorative grooves. He measures these grooves using a caliper to ensure they meet the specifications of the design. The craftsman drills a hole to create what's called a projecting mount. It's made of imitation ivory, and at 5 centimeters in diameter, it fits on the drone like a washer, but it's just for decoration, one of 7 on the bagpipe. He adds a metal component called a slide, also for decoration. Next, he turns what's called a blowpipe. This one's made of plastic to withstand moisture from saliva. Traditionalists prefer blowpipes made of wood. He adds a mouthpiece. It retracts by 20 centimeters depending on the player's height. The player blows into the mouthpiece to inflate the bag. A small metal tube between 2 plastic blades forms the chanter reed. When air strikes it, the reed vibrates inside the chanter, a pipe at the bottom of the instrument that has 8 finger holes for notes and 2 for pitch adjustment. To secure it, the craftsman wraps the reed with hemp string and winds Teflon tape over the string for an airtight seal. Then a brass wire called a bridle to control the shape of the reed. Narrowing the opening produces a higher pitched sound. The craftsman ties hemp string to create traction between the drone segments, holding them together. Hemp string is especially durable, yet easily replaced if damaged. Here's the completed tenor drone. Next, a craftsman inserts what's called a stalk through the zippered opening of the pipe bag. The pipe bag's made of synthetic, breathable material. The 5 stalks fit through a rubber collar in the bag, attaching to the 3 drones, the chanter, and the blowpipe. The craftsman inserts the chanter through a sleeve in the bottom of the pipe bag. He secures it with string, tightening it around the bag. He closes the zipper to form an airtight seal. Next, he places the pipe bag into a decorative velveteen bag cover. He inserts the stalks through holes trimmed with wool or silk fringe. A rubber valve prevents the player's air from coming back up through the blowpipe, channeling it through the chanter instead. Another part, called a drone reed, acts like a plastic tongue. It vibrates over a long hole to create the bagpipe's humming sound. The craftsman inserts the drone reed into the drone and then into its stalk. Wool cords keep the drones in place while the player plays. Finally, the craftsman fits the chanter reed into the chanter, then slides it into its stalk. A bagpiper must have a strong set of lungs because some songs can run for 20 minutes. Now that's long-winded. A Yule log is a traditional dessert for Réveillon, the Christmas Eve meal that follows midnight mass in France and French Canada. It's a rolled sponge cake covered in chocolate frosting and decorated to look like a tree log. It's supposed to represent a real Yule log, the burning of which was once a popular Christmas ritual. This company uses vanilla or chocolate ice cream instead of frosting. The cake itself is chocolate sponge cake. Workers start by making chocolate cake batter in a machine called a liquefier. They add flavoring, exactly what is a trade secret, and liquid eggs, binding agents, butter oil, sugar, flour, and cocoa. After mixing the batter for 20 minutes, a machine called the cake depositor pumps it into a 50-liter vat. The cake depositor distributes the batter evenly through nozzles spaced 9 centimeters apart. Then it spreads the batter onto brown craft paper that's about 1 meter wide. The paper's waxed so the cake won't stick after baking. The machine funnels the batter into an even layer that's 6.5 millimeters thick and 91 centimeters wide. Workers make between 8 to 10,000 Yule logs daily, depending on the size. After baking for 7 minutes at 260 degrees Celsius, a conveyor moves the cake out of the oven at 1.8 meters per minute. Next, a circular saw separates the cake right down the middle. Every 17 seconds, another blade, appropriately called a guillotine, drops down, slicing the cake into smaller segments. A machine pours strawberry jam onto a thick layer of ice cream. This creates 3 layers, including the cake slab underneath. The factory goes through 1,800 kilograms of jam and 12,000 liters of ice cream per 8-hour shift. A worker gently separates the cake slabs, leaving about 8 centimeters of excess ice cream and jam, which is thrown away. She then separates the cake from the craft paper by folding the cake onto itself once, then rolling the cake, ice cream, and jam layers together. Watch closely and you'll see that she doesn't touch the cake, only the paper. She wears rubber gloves to prevent her hands from sticking to the paper. The worker rolls the cake into a machine called a slicer. It cuts the cake into 3 20-centimeter long segments called logs. The slicer deposits the logs into plastic trays. Another machine now decorates with ice cream. It covers the surface as well as the ends. The ice cream decorations are lace and floral designs. Now for the embellishments. Workers place 2 candied maraschino cherries on each log. Then a machine drizzles on bits of maple sugar as another worker cuts the connecting ice cream, separating the logs. This factory uses maple sugar bits instead of nuts on its logs, out of concern for allergies. Next, a plastic poinsettia on each log. Then a plastic Joyeuse Fête, French for Happy Holidays. A conveyor belt moves the logs through a machine called a CO2 tunnel. Inside, sprayers blast the logs with a mist that instantly freezes them. This mist is carbon dioxide refrigerated to -85 degrees Celsius. 5 minutes in the CO2 tunnel super freezes the outer layer so workers can handle it easily. A wrapping machine covers the logs in a clear plastic film. Then another machine simultaneously cuts and heat seals the plastic, enclosing the logs in bags. Finally, a worker packs the bags into boxes for shipping. The factory stores the boxes in its warehouse freezers at -35°C. Then, as Christmas approaches, these holiday desserts go out to the stores where they sell for $5 to $8 each. If you take your fishing seriously, chances are you're hooked on lures. If worm bait is like hamburger, then lures are like filet mignon. They attract fish by either mimicking the food they like, impersonating a minnow, for example, or by reflecting light. Lures come in many shapes and sizes. They can measure up to about 30 centimeters long and weigh as much as 400 grams, about as heavy as a cell phone. They're usually made of brass. This model is from a brass sheet that's less than a millimeter thick. It goes into a press that's outfitted with a series of dies to progressively cut and shape the lures, churning out 2,000 of them per hour. This looks like one fast operation, but it's really 4 consecutive steps. The first die stamps the company name and lure model number, punches a slot down the middle, and punctures a hole on each end. The second die scores the outline. The third cuts it out. The fourth and final die forms the piece into a spoon shape, which is why this type of lure is called a spoon. This shape makes it move in the water like a small fish. That blue object at the bottom right is an air jet. It blows the lures coming off the press into a collection bin. Lures vary in size, shape, and texture, and plating them in different metals creates different reflective effects in the water. All these factors determine the type of fish the lures attract. The metal plating process is called electroplating because electricity is the key to it all. Workers wire up the lures, submerge them in an acid solution, then run a negative current through them. They run a positive current to the plating metal, in this case copper nuggets. The acid dissolves the copper into particles laced with a positive charge. This draws them to the negative charged lures, which they coat in an even layer of copper. After a thorough rinse, the racks go into the next tank for nickel plating. Then another rinse and into another tank for silver plating, the final finish. Silver plating requires undercoats of copper and nickel. To prevent the silver from tarnishing, workers coat the lures in clear lacquer using the same plating process. Lures plated in 24-karat gold don't need lacquering because gold doesn't tarnish. Now for the cosmetics. One way to decorate the lure is by what's called pad printing. An automated machine applies ink to a metal plate with a design etched into it. A silicone pad stamps the plate, picking up the design, then stamps the lure, transferring it. This is a 2-color design, so there are 2 pads at work. It's quick-dry ink, so the colors don't smudge. Another way to decorate lures is to apply decals. They adhere with waterproof glue that's specially designed for the fishing industry. After decorating, workers attach a 3-pronged hook, a treble hook, to a split ring. That's the ring at both ends of the lure to which the fishing line and the hook will be attached. Some models have decorated hooks known as dressed hooks. The idea is to add a color accent to make the lure look more like the fish's prey. To do this, they first wind a nylon thread around the shaft of the hook, then trim off the loose end. Next, they lay together 2 different colored hackles. Hackles are the filaments of a rooster's neck feathers. They wrap them around the shaft of the hook on top of the nylon thread. The different colored feathers blend together, the filaments projecting from the head of the hook to disguise it. Workers wrap them with more nylon thread to secure them in place. Here, a decal is applied to a different style of lure, called a spinner, because it spins like a disco ball, reflecting light to attract the fish. The final step is to attach the hook to the lure. Depending on its complexity and number of platings, a lure takes between 45 minutes and 2 hours to make. That's a lot of specialized time and effort for fish bait that's nothing short of alluring. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.